Okay. Yeah, hi. Hello everyone. Welcome to my YouTube channel, Panda Cloud. So in this video, we will be discussing about the DevOps project. Okay, so we will be discussing how to integrate all the DevOps tools like GitHub, Jenkins, SonarQube, NPM, Trivy, Docker, and how to push these images to ECR repository. Then how to pull the image and deploy it in the AWS ECS. And also with the help of Helm charts, we will see how to create Grafana, Prometheus. So these are the monitoring tools that we'll be using. And we will be using Terraform as an IAC tool to create the infrastructure. So basically, we'll be creating the Jenkins server with the help of Terraform code. And we will be creating the AWS EKS with the help of Terraform only. So you may have, the previous video which I had uploaded on YouTube, which was regarding the DevOps project, we had used these tools. And we had seen how to use Kubernetes with the help of KubeADM. And we had used Maven because we were using a Java code. In this, we will be using a different code. And, we will be, uh, and we will be creating the build. We will be using the Node.js code and we'll be creating the build. Previously, we had used the Maven tool in the DevOps project number 1. But in this project, we will be using NPM. So this is a build tool that we'll be using. So NPM is a is a package manager, as well as it can be also be used as a build tool. So these are the tools that we'll be using in this project. So this video is for the candidates who are already familiar with the AWS and DevOps concepts. Okay, so and the candidates who are already aware what DevOps tools are, how these tools work, and how we can use Terraform to create the AWS infrastructure, and how we can use AWS CLI and all these things. In case if you are not familiar with AWS and DevOps concept, then we are already starting a new batch from 21st of October. This is the AWS batch that we are starting, and you can enroll in this batch and you can get more clarity on AWS and DevOps concept. So DevOps batch will be starting from January, and from 21st of October, we have started an AWS batch. So the code credit goes to Nikhil Manglik. Okay, so we have taken the code from Mr. Nikhil Manglik, and he has created this code for to deploy the Amazon Prime Video. So you can simply search him also on GitHub, and this is where we have taken the Prime Video code. So you can just click on this codes and you can fork it, and this code will, you can just easily pull up this code in your GitHub repository. All right, then we will start with the project. So as I told you, we will be using these tools. So basically what we are going to do is we are going to deploy a Amazon Prime Video clone, and we are going to use Terraform as an IAC tool to create the infrastructure like EC2 instance, like as in we will be creating the Jenkins server, and we will also be creating the AWS EKS with the help of Terraform. GitHub we are using as a source code management tool. Jenkins we will be using as a CI continuous integration tool, or mostly CI/CD automation tool. SonarQube will be using as a quality code analysis and quality state tools. NPM will be using as a build tool for Node.js project. So as I told you, this project is Node.js project, and NPM also can be used as a package manager, and it can also be used as a build tool. Trivy we will be using to check for any vulnerabilities. Docker we will be using to create the images. We will be creating the Docker images with the help of Docker, and we will be pushing the images to AWS. Yes. So in the previous project, we had seen, or we had used Docker Hub to store the Docker images, And here, over here, what we will do is instead of Docker, we will use AWS ECR. So you are familiar, so you will get familiar how to use AWS ECR to store the Docker images. Then we will be using AWS ECS as a container management tool. ArgoCD we will be using as a continuous deployment tool. So we'll be doing the deployment with the help of ArgoCD. So in the previous DevOps project number 1, we had seen how to deploy it with the help of deployment and service manifest. So this time we are doing it a bit different. We will be using ArgoCD as a deployment continuous delivery tool, and we will be we will be deploying our Amazon Prime application. Also, we will be using Hem. With the help of Hem, we will be creating the Grafana and Prometheus applications, and we will be using them as a monitoring tool. So we will be monitoring the CPU, RAM, and the status of the pods with the help of Grafana and Prometheus. Now, before moving ahead with the project, let us discuss some prerequisites. So we will discuss some prerequisites. So the prerequisites are AWS. You will be needing an AWS account. So in case if you're not familiar how to create an AWS account, I have given the link in the description. So you can refer that link and you can see how to create an AWS account. Secondly, we will be needing AWS CLI, which will be installed in your local machine. So AWS CLI is required to run the AWS commands. So if you want to do the configuration, or if you want to configure your AWS account with your local machine, for that we will be needing AWS CLI. And we will be needing Microsoft VS Code, although this is totally optional, but I would recommend using this tool as a code editor. Okay, instead you can also use command prompt if required. If you are very much having a good hands-on with command prompt, you can use command prompt instead. But I would suggest using this Microsoft VS Code as a code editor. This is very much flexible. It has several plugins, and the description for creating the AWS accounts, to set up AWS CLI, and how to install VS Code in your Windows laptop. Everything has been given in the video description, and it is also available on my GitHub account. So this is my GitHub account with the name PandaCloud1, and from here you can find the README file. And in the README file, you will be able to fetch the details of setting up AWS, how to create your AWS account. This is a free account. So you can create an AWS account and you can access it for 1 year for free. So this is the link to set up AWS CLI in your local machine. And VS Code, as I told you, this is totally optional, but you can use it to download and install VS Code, and you can use it as a code editor. So this is the link. These are the links that are available on GitHub, and it is also available on the video description. Now let's move ahead and see how to what are the configuration that is required that needs to be done. So let's see what do we need to do. So we need to integrate, or we need to configure our local laptop or our local machine to be able to use the AWS account. Okay, so for that we will be needing to create an IAM user, and we will be needing to also create the access key and secret key out of it. Okay, so this access key and secret key we will be using to configure our AWS accounts with our local machine. Okay, so this access key and secret key will be created by creating an IAM user. So we will see how to create an IAM user and how to generate the access key and secret key. And along with that, we will also create a PEM key. Okay, so this PEM key we will be using to access or to do this SSH access to our EC2 instances. So first thing we will see how to create an IAM user. So for that, what we will do is we will go to our AWS account. So once you log into your AWS account, over here, just search for IAM. In the services, search for IAM and click on this IAM. And on the left hand side, you can find an option called as users. Click on users. And here, select create a user. So let's say I am creating a user for DevOps project. You can give any name of your choice and just click on next. Over here, click on attach policies directly. And from here, just give the admin access to this user. So just at the bottom, you will find an option called as administrator access. Just select it and click on next and click on create user. So this will create a user. Okay, so instead of using the root user, you can just simply create an IAM user. And from this, for this user, you need to generate the access key and secret. So just go to your users, the user that you have created, that is DevOps project user. Go to security credentials, and at the third option you will find here called as something called as access keys, and click on create access key. Now the use case will be command line interface. Okay, that is what we will be using so that we can integrate our machine with our AWS account. To select CLI, just do the confirmation. Click on next. Give any description here, and this is totally optional. If you want to do description, you can give it. So this is an AWS access keys secret key, and just click on create access key. So this will generate an access key and secret key. Just copy this key and save it somewhere in your local machine. So let's say this is my access key, and this is the secret key. Just copy it, save it in a text editor like Notepad or anything. So we have saved our access keys and secret keys, and later on we will be also needing this access keys and secret keys in manage Jenkins credentials. Okay, so we will be also using this access key and secret key in the Jenkins credentials. So this is important. So I have saved my access key and secret key. So this is done. Continue. Now what we will do is we will also be needing a key pair. Okay, we will also be needing a front key so that we can do the SSH access to our EC2 instance. Okay, anyways, we will be using Terraform code, but the Terraform code, we will be needing a key. Okay, there is no automation to create a key with the help of Terraform code. So you need to manually create a PAM key and you need to use it in your Terraform code. So for that, go to EC2 service. Go to key pairs. Over here on the left hand side, you can find an option called as key pairs. And just click on create key pair. Okay, so here what you do, just you give the name as key. Okay, so I would suggest you to use the same name because that is the name I have used in the Terraform code. If you want to give some other name, you can give it. The same name you need to enter in the Terraform code. Okay, so I would suggest you just follow the same steps that I am following and start giving the same name so that it will be easy for you for a seamless integration. So give the name as key, and over here select the format as .pam and just click on create a key pair. So this will download a key pair in your local machine. Just open it in the downloads. Over here, this is the key. This is the key that I will be needing. Okay, I have downloaded the key pair in my downloads folder. So this is how you need to do the configuration. This is how you will be creating an IAM user. You will be generating the access key and secret key. And also we have seen how to generate the PEM key. Now moving ahead, we will see how to create the infrastructure using Terraform. So what we will be doing is we will be creating the Jenkins server along with the security group. We will be installing some packages. Okay, so we will be installing SonarQube. We will be installing NCM. We will be installing Trivy. We will be installing Docker. We will be installing other dependency packages in that, using the Terraform code. Okay, so that is what we will be doing. And also, we will be installing AWS CLI. We will be installing Trivy, and Java 17 is required for Jenkins. So that is a prerequisite for Jenkins. So we will be installing Java 17, kubectl, and these all packages will be installing in the with the help of Terraform. So for that, what we will do is just go to GitHub. This is my GitHub repository. You can just click on code and copy this code and go to your desktop. Just create any go to your desktop and create any folder. Let's say this is my DevOps project number 2. And just in the address bar, type CMT, that is command prompt. It will open command prompt in this folder, that is DevOps project number 2. And here, just try to clone the GitHub repository. So the command to clone the GitHub repository is git clone followed by the repo name. So I have mentioned the command over here. Just copy this command, git clone followed by the repository name, and it will clone the repo in your laptop. So just copy, paste it, hit enter. So this will clone the DevOps project, and after that, what you do is change directory DevOps project number 2, and over here you just type code dot. So if you type code dot over here, it will open VS Code in this particular path. Okay, so this path will get opened in VS Code, and all the folders will be accessible from the VS Code. So just type code dot, hit enter, and it will open VS Code in the backend. And if you want, you can just close this command. It's not required. So these are the files that you will be using to create this DevOps. So over here, this is the Terraform code, wherein I have stored the Jenkins server and EKS code. This is the Docker file we will be using later on. And this is the readme file you can refer. And in the Kubernetes file, we have the deployment and service manifest. In the pipeline script, we have all the pipeline scripts, the build pipeline, deployment pipeline, cleanup pipeline. We will be using it later on. So for us, the important part is this Terraform code. As of now, we will see how to create a Jenkins server with Algo by writing the Terraform code. So just click on Terraform code, go to EC2 servers, and this is the main file, main.tf file. Okay, over here you can see what it is going to create. It is going to create, first it will create a security group which will be required for Jenkins server. So over here we will be using the SSH ports for 22.4, HTTP port number 80, HTTPS, and these are the additional ports that will be required by Kubernetes kubectl. So this is the NPM 4 port, that is 3000. This is the Kube API server 6443, Jenkins port 8080, SonarQube port 9000. SonarQube uses port number 9000. Prometheus uses the port number 1990. And another port, that is 9100, which is used by Prometheus metric server. And these are the additional Kubernetes ports that I have added. And we will be creating the AWS EC2 instance, and we will be doing the SSH, and we'll be installing the packages. So we'll be installing the CLI, installing the Docker, and this is not required. Prometheus and Grafana will be installing as a ham. You can ignore it. SonarQube will be installing as a container because SonarQube has several steps for installation. So we will be using it as a container. We'll be using installing AquaTrivy. We'll be installing kubectl. We'll be installing ham. We'll be installing ArgoCD as well. And we will be installing Java 17, which is a prerequisite for Jenkins. We'll be installing the Jenkins. Then we will pull out the Jenkins username and password from here. Okay, so it will also give you the output of the Jenkins password. So no need to go and SSH inside your server to get the password. Everything is automated by writing this main.tf files. Another thing that I will be needing is I need the C over here in this location. So wherever I have this main.tf file, I will be needing the c.pem over here. So what you do, go to your downloads, copy this key, and go back to your Terraform code and just paste it over here with the help of Control D. So this is the PEM key. Okay, I will be needing it in the same path as your EC2 server code. Okay, and after this, you will be able to run the Terraform command. What we can do is, first we will do the AWS configuration, because we need to integrate our local machine with our AWS account. For that, we need to enter the access key and secret key. So that is what we will do first, and after that, we will run the Terraform command. So another prerequisite is Terraform in your Windows machine. So how to install Terraform is that is the link that will be provided in the description. So in the video description, you can get the link on how to install and configure Terraform in your machine. Now once this is done, just right click and click on Open in Integrated Terminals, and this will open a terminal for you over here. Okay. Now this path is too big. If you want to reduce it, you can do it by running some code. But if you don't want to do it, that is fine. But for me, it takes a lot of space. So just run these 3 commands over here. So it will just reduce the path. This is totally optional. If you feel like doing, you can do, or you can just skip just. So you can see here, now it will just display it as a PS. Although you are in the same path, but it has reduced the long path to short, so that you can see the commands that I will be typing over here. So the first thing that I will do is I will integrate my laptop with my AWS account. So for that, the command is AWS configure. Hit enter. I will even ask you to provide the access keys and secret key. So we have already saved it in our notepad. So this is my access key. This is the secret key. And the default region is US East 1. So if you want, you can, if you are using a different region, just type the region name over here. Or you can keep it blank if you are using US East 1 and just hit enter. So now your laptop is configured with your AWS account. Now it can run all the AWS commands, or you can simply automate Terraform code, with your AWS account. After this, what we will do is we will run the Terraform code with Terraform command. So the first command is Terraform init, which will help you to initialize your machine, right? So it will download the AWS provider plugin in your Terraform folder, right? Over here, it will create .terraform folder and it will download the AWS provider plugin. It will do the initialization. And after that, we need to run the next command. First, we will run Terraform init. So it will download the provider plugin in the backend, and here .terraform folder will get created. No. No. So you can see here .terraform folder got created over here. This is the hidden folder in which you can fetch the AWS provider plugin. Now, you can get getting a message that the Terraform has been successfully initialized. Now, I will run the next command, that is Terraform plan. You can run if you want to check what it is planning to create. I have already checked the code. So I will directly apply it with the help of Terraform apply. And I will use the flag -- auto approve, so that it will not prompt me for a confirmation, yes or no. It will automatically set it as yes. So I'll just run the command Terraform apply -- auto approve. The moment I run the command, it will take around 5 to 10 minutes to create the infrastructure. Okay, so it will create the Jenkins server. It will install the required packages, right? It will install AWS CLI. It will install Docker. It will install SonarQube. It will install Trivy. Java 17, Jenkins, kubectl, etc., etc. So this creation will take around 5 to 10 minutes. So we will wait for 5 to 10 minutes, and then we will see how to move ahead. Around 2 minutes and 32 seconds, around almost 3 minutes for creating this infrastructure. So over here you can see in the output I have automated everything. So it will give you the Jenkins server URL. It will give you the initial login password. It will give you the URL of SonarQube. It will give you the username and password for SonarQube. It will also give you the Grafana server access. But we won't be needing this because this is what we will be installing as a from using ham. Okay. So moving ahead, we will see how to do the configuration of SonarQube. So for that, what we will do is we will pick up this URL, Jenkins over URL from here, copy it, open it in your browser. So you can see here Jenkins has been set up in your system in your EC2 instance. Now here it is asking for administrator password. So we will just pull out the password from here. So this is the password. We'll paste it here. Continue, and we will install the suggested plugins. Meanwhile, while the plugins are installed, we will see how to configure SonarQube. So what we will be doing is we will be setting up the webhook, okay, and we will be generating the token, okay. So the webhook is required to integrate your Jenkins with your with SonarQube. So it is used to send the real-time notifications to other systems. So over here, we are taking as Jenkins. So SonarQube webhook will send the analysis results, whatever analysis it will do, it will send it back to Jenkins. So that is the reason why we'll be needing the webhook. Second thing that we will be needing is the SonarQube token. Okay, so this token is required to do the or to provide a secure communication between SonarQube and other tools. Okay, as in what we are using it over here is Jenkins. So if you want to do a seamless integration or if you want to do a secure communication between Jenkins and SonarQube, and for that what we'll be needing is a token. So we will see how to create the webhook, and we will see how to create the token using SonarQube. So for that, what I will do is I'll pull up this URL from the output. So this is my SonarQube URL. Copy it, and the username and password is admin. Okay, so I'll just copy the URL, paste it, and over here in the Jenkins, I'll just set the create a user. I'll create the user with the Panda Cloud account. Okay, so this is how we will be starting with Jenkins. Now we will see how to create the webhook and token in SonarQube. So the login admin user and password is admin only. So just log in it, and you need to change the password for the first login. So the old password is admin. New password is you can set any password of your choice. Okay, so the password has been changed successfully. So the first thing that we are going to do is we will first create the webhook for SonarQube. So this webhook is used to send the real-time notifications to Jenkins. So, okay, so for first thing that we will do is we will configure the webhook for SonarQube. So for that, what you need to do is just go to administration, go to configuration over here, and click on webhooks. So this is where you can create the webhooks, and here just click on create and give any name. So whatever name you want to give, you can give. I will just keep it as SonarQube webhook, And over here you need to mention the Jenkins URL. So just copy the URL from here, paste it, and just copy this SonarQube webhook and add it, after this forward slash. Okay, so this is required. This is must. Okay. And after this, what you do is just click on create. So this is how you can create a webhook for sending real-time notifications to Jenkins. Now we will see how to create the token. So for that, go to security, go to users. If you want, you can use the same admin user, or you can create another user if required. You can just create a user and you can generate a token. We will use the same admin user only, and just click on this tokens, update tokens, and here give any name. So I'll just keep the name as Sonar token and click on generate. So this will generate a token. This is the token that we will be needing to store in our Jenkins. Okay, so we will be needing to store this in our Jenkins. Okay, and this token is used to integrate SonarQube with Jenkins, as I told you already. So just copy this token. Now, how to store the secrets or credentials in Jenkins? So for that, go to Manage Jenkins. Go to Credentials over here. Here you will find System. Go to System. Go to Global Credentials. And here, you will find an option called as Add Credentials. So just click on Add Credentials, and here you can add the credentials. So what is the kind of credential that you need to store? Is it a username with password or GitHub app? You can select. So this is just a key. Okay, this is a token. So for that, you can store it as a secret text. Paste the secret over here. Okay, just copy the secret and paste it here, and give any ID, whatever ID that you want to call it in your pipeline code. So I will call it as Sonar token, and just do the same description over here, and just click on create. So this is how you can store the secrets in Jenkins. Okay, so manage Jenkins and credentials, and from there you can add the credentials. Now we will be also needing to add two more credentials. That is the AWS access key and secret key. Okay, so we will be needing this so that we can run the AWS ECR and EKS commands from our Jenkins. Okay, so that is the reason why we'll be needing to store this access key and secret key. So we will be needing to integrate the AWS services, the ECR and EKS. Okay, so that is the reason why we'll be needing these, credentials. So just click on Add Credentials. Here, select Secret Text, and this is where you will be needing to paste the secret. So we have already stored the secret here. So this is my access key. Just copy this, paste it here, and give ID, any ID that you want to give. I will give it as access hyphen key. Same description, I will paste it here, create. So I've created the access key. Again, I will also store the secret key. So for that, again, select secret text, copy the secret key, and paste the secret over here, and give the name as secret key, and click on create. So these are the three credentials that we will be needing. We will be needing the Sonar token, we will be needing the access key, secret key. So as I told you already, so we will be needing this access key and secret key, so that we can integrate the AWS services like ECR and EKS. So that is the reason why I will be storing this access key and secret key. Now moving ahead, we will see how to configure Jenkins, right? So we will see, we have already seen how to set the credentials. So this part is done. We will see how to install the plugins in Jenkins. Then we will see how to configure the system and tools. So we will check this one by one. Now we will see how to set up the plugins in Jenkins. Now plugins are required so that you can have a seamless integration with other tools. Okay, so these Jenkins provide several plugins. Okay, that is provided by Jenkins. So whatever default plugins are there, we will be needing some additional plugins. For example, we'll be needing the SonarQube plugin. Then we'll be needing the Node.js plugin. We will also be needing the pipeline stage view plugin so that we can view graphically the different stages of a pipeline. We will be needing the Docker plugins, and we will also be needing a Tamarind installer plugin. So that is used so that we can install OpenJDK. Okay, so those plugins also will be needing. So we will install these plugins one by one. So for that, now how to install plugins? Again, go back to Manage Jenkins. Go to plugins over here, and here click on Available plugins. Because if you want to install anything, you need to click on Available plugins. And over here, we will install some plugins. So what all plugins we'll be needing is the first plugin will be needing a SonarQube scanner. Then we will be needing Node.js. Node.js. Then we'll be needing the pipeline stage view. This one. Then we'll be needing the Eclipse Tamarind plugin. So this is required for Node.js. Okay, so this is the JDK tool that downloads the JDK from Optium.net. So this is required, and all the plugins related to Docker. So just search for Docker and install the plugins for Docker. These are the all plugins required for Docker. We will also install the Prometheus metrics. We will be needing this later. So this is the additional plugin. Just click on install. So it will install all the plugins and do a restart if required. So after these plugins are installed, just click on this option, restart Jenkins, and it will restart Jenkins in 2 minutes. Restarted now. Now I need to re-log in. Okay, now we will see how to configure the system. Okay, now in the system, what we will be doing is we will be, we'll be setting up the SonarQube server in Jenkins. Okay, although this part can be done by directly by writing it in the pipeline code, but instead of specifying it every time in the pipeline code, it is better that we do the configuration uh, once. Okay, so we will see how to set up the SonarQube server in Jenkins with the help of Jenkins system. So for that, go to again go back to manage Jenkins. Go to system over here, and here we will set up the SonarQube server. So we need to integrate the Jenkins with SonarQube. From the SonarQube part we have done. Now from the Jenkins part also we need to integrate a SonarQube server. So just scroll here. You will find an option called as SonarQube servers, and in that you will find an option SonarQube installation. So just click on add SonarQube, and here you can give any name. So I'll just keep the name as Sonar server, and this is the SonarQube URL that you need to add over here. Okay, so here that you can copy the URL from here. So this is the URL. Paste this, and here you can see there is no forward slash after 9000. So just remove this forward slash. So just keep it like this in this format. And in the token, just select the token that we have created. That is the Sonar token. So this is the token that we have already created. So select this token and just click on save. So this is how we can set up the or integrate the Jenkins SonarQube server with Jenkins. Now moving ahead, we will see how to configure the tools in Jenkins. So see, you can configure multiple tools, and the advantage of configuring tools in SonarQube is that you can use different versions of tool in different pipelines. So let's say you have 10 pipelines and you want to use 10 different versions of a tool. You can do it with the help of this global tool configuration. So that is one advantage of tools that you have in Jenkins. So let's say, for example, if I'm using JDK 16 in one of my pipeline code, if I need JDK 16, I can use it in I can do that. In another pipeline, let's say if I'm needing JDK 18, I can do that. In another pipeline script, if I'm needing some different version of JDK, and I can do it. So that is the advantage of global tool configuration, is that first thing that you don't need to specify each and the tools each and every time in your pipeline code. That is one advantage. Secondly, you can use the different versions of tools in your pipeline code. So that is the another advantage of setting up these tools in Jenkins. So for that, what we will do is we will go to manage Jenkins, and we will set up some tools. Now, what are the tools that we will be needing? So we will be needing the no, we will be needing the JDK tool. Over here, what we will do is we'll be using the version that is JDK 17.0.8. Then we will be needing the Sonar scanner tool. Okay, and we can use the latest version. That is fine. Then we will be needing this Node JS tool. And for this code that I have taken, we will be needing the specific version that is 16.20, 16.20. Okay, so this is the version that we will be needing. And Docker we will set up. So Docker also you can use the latest version. So this is the advantage. Okay, so you can configure the different versions in Jenkins, and also if you want to use some different version, also you can add it. Okay, so that is an option that is available. You can add multiple versions of the same tool, and you can use it in your pipeline code. Okay, so we will see how to do it. So for that, go to Jenkins, go to tools, and over here you can find first option, that is JDK installation. So add JDK. So you can give any name. I'll just copy this or ease, paste it here. Click on install automatically, and just over here, this is the Optium.net. That is the reason why we installed the plugin, Eclipse Tamarind plugin. So because this option will not be visible without that plugin. So this is how you can do it. And over here, I told you we will be needing 17.0.8, this one, this version. Okay, so this is how you can add the tools, and you can select the version of your choice. Now, let's say if you want to use multiple versions, you can just add JDK over here. Again, let's say you want to use JDK 20, you can just give another name. Here you can give the name, let's say just for easy understanding, you can give the name as JDK 17. Here you can give JDK 20. Here again you can add the installer, and here from here you can select the different version. So let's say this is JDK 20, and this tool name or this name you need to give it in your pipeline script. So this is how you can set up multiple versions of your tools, and you can use it in your pipeline script. Now, anyways, I won't be needing this. I will just delete it. I will only be needing JDK 17. You can keep it as JDK or you can keep it as JDK 17. Then we will be needing SonarQube scanner. So here, just click on add Sonar scanner. Just copy the same name here, paste it here, and this version is fine. Whatever version is there, I am fine. We are fine with that version. And here we will be needing the Node.js. Just add Node.js, and we will be needing the specific version that is 16.20. So just copy the same name, and from here just select the version that is 16.20. So this is the version that we will be needing for this code. Whatever code that we have used from the internet, so that code we will be needing. Okay. And lastly, we will be needing this Docker. So this Docker you can find, you can just copy the same name, paste it, click on install automatically and select docker.com. And the version is latest is fine. So just click on save now. So this is how you can integrate the tools with the help of Jenkins. Okay, so and you can use multiple versions of your tool if required. Now just I will give you the overview of the build pipeline. Okay, so we will create two different pipelines. Although if you want, you can create a same pipeline as well. That is totally up to you. You can create the same continuous integration and continuous delivery pipeline, or you can that CI is also called as build. You can and continuous delivery. It is also called as continuous delivery or continuous deployment, or it is also called as just a deployment pipeline, or you can call it as a release pipeline. So there are several names, but all means the same. Okay, so I'll just give you an overview of what we are planning to do in the build pipeline. So we will just do the git checkout. We will check out the code from GitHub. We will pull the code in our Jenkins. Okay, then so we will pull the code in Jenkins. Then will be doing the quality analysis and get quality gate with the help of SonarQube. We'll be building the Node.js package with the help of npm. We will use the Aqua Trivy tool. So this will help us to scan for vulnerabilities. We will use Docker to create the Docker image, and we will create this image of Amazon Prime clone. Okay, so this image we will create, and we will push this image to ECR, AWS ECR. So ECR is similar to Docker Hub. So Docker Hub is used to store the images. Okay, there previously we had seen um, how to store the public images. Here over here we will see how to store the private images. So in AWS ECR, that too specifically we will store the private images. So this is what we will see. So it will create the AWS ECR image. It will store the images in AWS ECR, that too in a private format. And also after the image has been pushed to AWS ECR, these images will be stored in Jenkins server, and that will just occupy some space. So we need to clean up these images. So we will also see how to clean up the images from the Jenkins server. So because that is also required, right? So we will also be needing to clean up the images from Jenkins. Okay, so once these images are stored to AWS ECR, we won't be needing it inside the Jenkins server. So we will just do the cleanup. Now what we will do is we will just see how to create a pipeline. Okay, we will create a simple pipeline. So let me call it as a build pipeline. You can call it as build pipeline. You can call it as CI pipeline, continuous integration pipeline, etc. So over here I'll select pipeline and I'll click on OK. And here what we will do is you can just generate the pipeline script over here like this. So this is just a simple word, a hello world pipeline. Click on save. And if we just run it, it will run the pipeline. Okay, so I'll go to build pipeline, click on build now, and it will just run the pipeline. You can see here, if I check the logs, this hello world message is printed. So this is how it will generate a simple pipeline. So we will use that syntax that has been generated to create our pipeline. So this is our pipeline script. We'll copy it and we will just store it in our editor. So this is where you can add the stages. Okay, these are the different stage. Okay, this is how you can start adding the different stages. So the first stage that we will be needing, as I told you, we will be needing to pull the or do the git checkout. We will be needing to clone the um, we will be needing to clone the GitHub repo. Okay, so we will see how to generate this. Uh, we will see how to generate this. You know, Git checkout stage. So for that, what will be needing to do is here I will add this at the stage as Git checkout. If you want, you can give the number as 1. that is git checkout. Now we will be needing to see how to do the git checkout. So for that, the the simplest way is just click on this. After you go to configuration, you can see something called as pipeline syntax over here. So just click on pipeline syntax, and here select git and give the repo github repo and the branch name. So this is my github repo. So just copy the URL from here, select the SSH part, copy the URL, I paste it in the pipeline syntax. And what is the branch? So here you can see the branch is main. So this is my main branch. I'll just copy it here, paste it here, and over here it is asking for credentials. Now since this is a public repository, I don't need to give any credentials. But if you are using a private repository, you need to generate the GitHub token, store it in the Jenkins credentials, and here you can just add the credentials over here. Now since this is a public repo, we will not be needing to add any credentials. But in case if you are using a private repositories in your organization, then you will be needing to generate the GitHub token from GitHub. You need to store the token over here, and you can just use that token, right, like this. So we don't need to use this credential because this is a public repository. Now how to do this, we had already discussed in our DevOps batch, how to generate the token, how to use this GitHub token. So that part we have already discussed in our DevOps batch. So just click on generate pipeline script. So it will give you this script. Copy this and just paste it here under the steps. Now, just for to make it more organized, you can just use a next line. So this is the first stage, right? We will be needing to do the git checkout, right? So we will be needing to add the first stage. Now, second stage, what we will be needing is we will be needing to do the SonarQube analysis. Right? We will be needing to do the SonarQube analysis. Now, for this also, we will be needing to generate the pipeline script. So I'll just add another stage here. So stage number 2, I will call it as SonarQube analysis. And here what we will do is we will generate the script from the pipeline script generator. So for this here, just select um, with Sonar something with Sonar environment. Yeah, with SonarQube environment, just select this, and there is no need to add any authentication token. Just click on generate pipeline script. So this is what we will be needing. Okay. Additionally, we will be needing to add that uh, Sonar server over here. Okay, this because this is the name that we have given here. I'll just open it. So manage Jenkins system, and here you have added this part. So this is what you need to copy and just paste it here. Okay, and you will be needing to write the script. Okay, whatever script that you need to run in your SonarQube environment variables. Now here what we need to do is we need to uh, you know uh, we need to run the Sonar scanner for a particular project, and we need to set the project key. So for that, we will be needing a environment variable, right? So what is the scanner home? So we need to store the scanner home somewhere. So what we will do is, if you want to set any environment variables, you can store it here like this. We can call it as environment. Okay, within this environment block, you can store the environment variables. So we will give the name as let's say scanner home. You can give any name. Okay, whatever name you are giving or whatever environment variable you are declaring over here, you need to use it over here. Okay, So you can give any name, Sonar Home equal to. So where have you stored the tool? So that is the SonarQube scanner. So go to Manage Jenkins, go to Tools, and over here you can see this one, this part. This is the tool that we need to use. Okay. So this will call the environment variable. So just give the name tool because this is a tool, right? We have added it as a tool, and just add the name here. That is sonar scanner. So this is the environment variable we'll be needing. Okay. Without this, the SonarQube environment, this part will not work. This block will not work. Okay. And how to call the environment variables? We can call it with the help of with an prefix dollar, right? So we will call this sonar home slash bin slash sonar scanner. So this is something that we need to run. And also we will be needing to add the project name and project key. So for that, the command is dsonar project name equal to any name that you want to give. Let me call it as Amazon Prime and hyphen d sonar project key. So I will give the same name, that is Amazon Prime only. So this is the command that is used to do the analysis, SonarQube analysis. Now, why do we need to do the SonarQube analysis? SonarQube analysis is used to check for any code duplications or code smells, or if there are any bugs with the code, or it will also check the security vulnerabilities. So these are the different things that will be done with the help of this uh, scanner. That is, it will scan the code and it will analyze the code smells, or what are code smell. Code smell is something that is wrong or it is poorly designed. So that is what code smell means. Technically it is called as code smell, but in simple language, code smell means that something is wrong with your code. That is what code smell means. And it will check if there are any complex codes, or if you have written any duplicate code, or you have, let's say, you have written a code of 100 lines, although you could have written it in 50 lines. So you have written it in a complex way, right? So 50 lines of code, for the 50 lines of code you have taken 100 lines of code. So that is what it will check. And so the reason why we need to fix the code smells, that means issues with the code, so that it will improve the simplicity of the code. It will be better for the future maintenance of the code. It will give you a good code quality. It will be better for good maintainability. So these are for these several reasons we need to do the SonarQube analysis. Okay, so SonarQube is a code quality tool which is used to check the code quality, which will analyze the code duplications, which it will check if the code, whatever code that you have written, it is a complex code. So all these things will be done with this SonarQube analysis. So that is why it is a very important tool. Mostly it will be used by the developers, so that they can check if there are any difficult or unnecessary lines of code that they have written, or there are any duplicate lines of code, or the code is poorly designed. So everything will be done with the help of this SonarQube. Okay, so it is a very important tool from the code quality and code quality and code analysis perspective. Okay. Now moving ahead, we will be we will be adding another stage, that is the quality gate. So what do you mean by quality gate? So quality gate, what it will do is it will set a gate. It will kind of create a gate like this. Okay, and the code should pass some percentage. Okay, so in order to the code to get qualified, it should pass some percentage. You can set any number. So let's say I will set 85%. Minimum 85% of the code should be passed. Okay, after this quality, after the SonarQube has done the code quality analysis and all. So this is kind of a gate. What is quality gate? So it is kind of a gate. It will just check the code. So let's say this is the code. The code should pass this gate, and the passing percentage is 85%. So this is, let's say, in simple words, let me tell it like this. So this is kind of a threshold. which will be set, or a gate. So in order to pass the gate, you need to at least have 85%, or you can set any number. That is totally up to you. You can set it 70%, 75%, 80%. So that number is totally customizable as per the developer. Let's say for example we have taken 85%. That it should, the code should pass at least 85%. If it doesn't pass, then the pipeline should stop. Okay, so this is what we need to do. Okay, and what we will do is we will just add this stage over here, that is quality gate. You can call it as SonarQube quality gate. So this is kind of a gate which will which will only allow the code to pass if if it has passed some percentage. Okay, it should clear, it should have that much of percentage. If that is clear, then it will allow the code, or else it will stop the pipeline. So for that, what again, how to generate this? For that, go to pipeline syntax generator, and here just select for quality gate, wait for quality gate. Okay, so it will check for the quality gate, and after that only it will allow the quality gate to pass. And we need to check, this SonarQube will check the quality. Okay, and the Jenkins will get the token from SonarQube. It will integrate SonarQube with the help of this token. Okay, so it will just integrate it with the help of this token. It will get the result from SonarQube, and then it will check if the gate is passed or not. So if the code has passed some percentage, it will proceed ahead with the pipeline, or else it will stop the pipeline. So just click on generate pipeline script. So this is the script that we will be needing. Just copy it, and just remove this part, paste it. So see, if the quality gate will pass, then only the pipeline will continue, or else it will abort the pipeline. So if the quality gate is false, then it will abort the pipeline. This is what it means. Okay. So this is the third stage, that is the SonarQube quality gate. Okay. So it will just allow the code. So the code should pass some percentage. So this percentage will be checked from here. So Jenkins, what it will do, it will pull up the SonarQube token. We have already integrated the token. It will go to SonarQube. It will check the result from SonarQube. It will come back. It will analyze the result. If the result has passed, if the result is true, then it will continue the pipeline, or else it will abort the pipeline. So this is what the quality gate will do. Now the next part that we need is, the next stage is, we will be needing the npm install. We will be needing to install the npm from the Node.js. So let me call it as npm install only. And we are using a simple command, that is npm install. Okay, that is a simple command you can use. Sh npm install. Okay, so this is another stage, that is, it will install the npm, right? And the next stage, as I told you, we will be needing to check the uh, application for any vulnerabilities. Okay. So what Trivy does it, so it will scan the application directories for any known vulnerabilities. Okay. Now, what is a vulnerability? Vulnerability means that there is a flaw in a system. That means that any that system can be easily misused by the attackers. Okay, so let's say you have done something, or you have done something. There is some issue with your system, which can help the attackers to easily attack your application. So let's say they can gain some unauthorized access. And what are the reasons for this vulnerabilities? It can be because of some code errors. Okay, let's say some developer he has mentioned the credentials or some confidential data within the code. Or let's say you have executed the code, you have deployed the code, and from the application the credentials are visible from the browser. From the URL, the access key, or or the username password is visible from the URL. Okay, so sometimes that can also happen. Or there is use of some outdated softwares, or there is some misconfiguration that is done. So these are the several vulnerabilities that can happen, that can be caused because of the poor coding practices. So maybe sometimes the developer has committed some confidential data within the code. So all these things are detected with the help of Trivy. So it is called as Aqua Trivy. So what it checks is it checks the vulnerabilities. So what are vulnerabilities? As I told, there is a flaw in a system using which the attackers can easily gain access to your application. So it is a very important security practice to check, check for any vulnerabilities, so that the code should not pass any secret data, or from the browser window the password should not be accessible, or the code should not be some misconfiguration, or let's say there should not be use of any outdated software. So these are the different vulnerabilities, and all this can be checked with the help of a tool called as Trivy. Okay, so this Trivy tool is the tool which will be used to check for any vulnerabilities, and that is the reason why we need to add that stage as well, so that it is a good security practice to check for vulnerabilities, right? So that your application should not be misused by any attackers. So for that, what we will do is we will use the uh, uh, we can add a stage called as Trivy scan. And there is a very simple command that is called as Trivy file scan, trivfs, in the current directory. And these, whatever results are generated, okay, so it will generate a result. So I will store it in a file called as trivy scan.txt. So I will just pull out the result, or you can just give any name. So let's say trivy scan results.txt. Okay, so what will happen is whatever vulnerability it has checked, it will generate a file, and we can access that file. Okay, so we will try to access that file, and we will see if there are any vulnerabilities. Okay, now the next stage that we will be needing is the Docker image build, right? So we will be needing to build the Docker image. Okay, so for that I've already written a Docker file, so you can check it from the code. So this is my Docker file. So what it is doing is it is pulling the node alpine image. Then it is setting the app as a work directory. You can set any directory of your choice. It is copying these JSON packages inside the app folder, and it will do the npm install, and it will copy the entire code, okay, that the code that is available on GitHub, to my app directory, and it is exposing the port number 3000. So this port number 3000 is the port that will help or that will help me to expose my application. So the application that I have created, that is a Node.js application, it will be running on the port number 3000. So for that is the reason why I need to expose this port number 3000, and I need to run the command npm start. Okay, so this is the command that will help me to start the application. So this application will be created within a container, right? So this will create a Docker container, this Docker file, and this container will host my application, and I will expose this container with the help of Kubernetes. Mostly we are using AWS ECR. So we will expose this application to the outside world with the help of Kubernetes, and that too we will use a load balancer, right? So we will use a endpoint as a load balancer, and from there we can expose our application. So this is how you can use this Docker file, and it will build the this application image. Okay, and these are the instructions that we have defined. So from this Docker file, we will create an image. So, so this is the stage, that is Docker image build. And what is the command? So the command is simple: Docker build -t. And here, what we will do is we need to tag it with some name, right? So let's say this is my name, or my image name. This is the tag that I need to add, followed by dot. Dot means current directory. So it will go to my GitHub. In the current directory we have, it will find a Docker file, and it will build the Docker image. Now this is something that I will, I will, let's say, variabilize. Okay, so let's say, this image name should be, it should be as per the input received from the user. You can give any image name, and it should give the image name like this over here. So for that, what you can give, you can just uh, let's say, we will generate it as an ECR repository name. Okay, we will create a repository, and the same name we will be using it over here. So for that, what I will do is I will call it as ECR repo name. So this is kind of a variable that I will be using over here, so that it can change as per the input received from user. So for that, we need to generate the parameters. So how to call the parameters? So the command is params dot ECR repo name, and if you want to call it, we need to add the dollar symbol. Now this is one parameter that I want to add in my pipeline script. So how to add the parameter? So we can add it anywhere here in the parameters block. And what is the parameter that I'm using over here? This is the parameter. Okay, so this is the parameter that I will be needing to add in my pipeline script. So what are parameters? Parameters are the input that you can take from the user. So this is what Jenkins will do. It will take the input from the user, and accordingly it will create the uh, or it will use it in the pipeline script like this. So this is the ECR repo, or, or let's say this is the parameter that I will be needing. And this is the parameter that will be called, or okay, whatever the user has declared within the ECR repo name. So let's say I have defined the name as uh, Amazon Prime, or let's say Panda Cloud, or whatever name I have defined. So it should pick up that name, and it should use that name within the pipeline script. That is what I need to or that is what my requirement is. Okay, so it will just pull out the parameter name, and it should use that name within the pipeline script. Now there is some format that I need to follow. So this is kind of a string. Okay, whatever name that is required. So you can define the string, you can define number, you can define boolean, you can define file within the parameters. Okay, so this is kind of a string. So just give the name as a string, followed by what is the name, that is ECR repo name, and you can set the default value as well, and this has to be within the quotes, single quotes or double quotes, any quotes. So what is the default value? So the default value is, so let's say I will set it as Amazon Prime, any name you can give, and you can add the description here. So what is the description? So let's say what input do you want to give to the user. So you can just give enter your ECR repository name. Any message that you want to give to the user, you can give it like this, and you can just close the braces. Right? So this is how. So this is kind of a string. So the variable name is ECR repo name. So the default value, if you want to set any default value, you can set it like this, or you can keep it blank if required. And you can add the description, which will just give a prompt to the user. So it will just display that the user to enter your repository name. Right? So we will see this how it will be useful in the pipeline. So what it will do is, let's say I have defined the name as Amazon Prime, or let's say I have given the name as Nasir image, anything, any image name that I want to give. Okay, it will create it accordingly. Okay, so it will create it as per the input received from user. So this is how you can make use um, of this stage, that is the image build stage, and I will just parameterize it so that I can use it, or so that it can help me to create any custom image name. Okay, I don't want any static image name. I want a custom image name. So that is what I will be using it over here. Okay. Now this is the stage that I have added. That is the image build. So I will give the number as the number 6. That is image Docker image build. Now moving ahead, we will add another stage, that is to create the ECR repository. Okay, so what it should do is it should create an ECR repository. So for that, what I will be needing is, there is a command. I will be needing to, I will show you the command. So AWS ECR create. CLI commands. So you can refer these commands. So this is the create repository command. Okay, over here. This is the command AWS ECR create repository --- repository name. Okay, so this is what I will be needing. Also, I need to before creating the ECR repository, my Jenkins is still not configured with my AWS account. My Windows laptop, my local machine is configured with my AWS account, but my Jenkins server is not configured with my AWS account. My Jenkins server is not aware which AWS account it should access. So let's say this is my Jenkins server, and let's say this is my AWS account. So this is the reason why we have installed AWS CLI in our Jenkins. So my laptop is integrated with my AWS account, but my Jenkins server is not integrated with my AWS account. Again, okay. So for that, again, we need to run this command AWS configure. Then we need to enter the access key and secret key, right? The same process that we have used for our to configure our Windows laptop. Okay, we need to run these commands AWS configure, AWS access key and secret key. But there is a different method with Jenkins, because see, these are this is what I need to write in a pipeline script. So how to do it? So first thing that I need is I will be needing to generate the credentials. Okay, so again I'll go to pipeline script. Here, go to with credentials. You will find an option called as with credentials. Okay, so what I need to do is I need to use these credentials in order to integrate Jenkins with my AWS account. So what are my credentials? One is access key and another is secret key. So I will go back to my pipeline script. Here the type was secret text. Now this here just select access key and give any variable that you want to give. Let's say AWS underscore access key. So this is again a variable that I will be calling. Okay. Not only I need a access key, I will also be needing a secret key. So here just click on add. Again secret text. Here select secret key and give any variable. So let's say AWS underscore secret key. Okay. So this is how you can generate the credentials. So just click on generate pipeline script. So this is the block that I will be needing. Okay. This is the block that I will be needing, and I will just paste it over here. So I'll just remove this part. Okay, so what it will do is it will before creating the AWS repository, it will first integrate Jenkins with my AWS account. Okay. Again, now for this, I will be needing to run this command AWS configure. Now you can just get the commands over here. AWS configure, set access key ID like this. So this link I will give. Okay, or you can just search it here. Over here, this is a link you can use. AWS configure, set AWS access key ID. Now this is the variable that I need to call over here, right? I have already defined the variable. Let me just copy these two lines. I will be needing to call the access key and secret key. I will just paste it here. Okay. Remove the dollar. Okay, and instead of this part, this one, I need to call the variable access key variable. This is my access key variable, and this is my secret key variable. So just copy this and over here just replace it with a dollar like this. Okay, so this you can get it from the link. Okay, so this is the link. I will give the link later. So I'll add the link in the description. Okay, so this is how you can pull out the access key and secret key. Now, what we will do is we will need to create AWS ECR repository. So this is the command. I will go back to my pipeline script and paste this AWS ECR create repository and followed by hyphen repository name. So what is the repository name that you want to give? Okay, so we will give the same name as a image name. Whatever image name I have given, I will use the same name. So I will add this parameters here also. Okay, AWS ECR create repository hyphen repository name, that is parameters dot ECR repo name. So whatever image name you have given here, the same image name and same repository name will be used. If you want, you can call another parameter. You can create another parameter with the name of as ECR repo name. That is totally up to you. Okay, so it will create the repository name with the name that has been defined by the user. Hyphen region. So what region you want to add, you can variabilize this region if required. Now mostly many of us we will be using US East 1 only, so I want variabilize this to avoid complications, right? Now this is how you can add the different stages. Now these are all shell script, so for that you can add sh. So either you can write sh colon like this. Every line you need to add sh for every line. Instead, if you want to just write it once, this is how you can write. So write sh followed by 2 3 quotes. So how many quotes I have added at the beginning? Just end it at the bottom with the same number of quotes. So I've added 3 quotes and use double quotes instead of single quote here. So I've added 3 starting. This is the starting quote, 3 starting quote. I will end it as 3 starting quote. So with the help of these, this block, you can add multiple shell script lines, right? Rather than writing sh followed by in every line, rather than writing sh, you can use it like this block. Now, one more thing that I want to do is that it should first check if the repository exists and then it should create. So for that, what I will do, I'll just copy this line and just paste it here. And instead of create, I will just write it as describe repositories. So it will first pull out the list of repositories. Okay, so that also you can find it here. AWS ECR describe repositories. Okay, so just search for AWS ECR. How to write the command? Okay, so this is the describe repositories. This command. Paste it here. Then again we have the hyphen repository names. It is names, okay, not name. So repository names. So it will first check if my Amazon Prime repository is there. Okay, if it is already existing, then it won't create the repository again. So that is why I have added this. Describe repositories hyphen repository names, Amazon Prime and US East 1. Okay, yeah, either you do check this, or if it is doesn't exist, then create a new repository. Okay, so this is the stage that I need to add over here. So this is the 7th stage, that is create ECR repository. The next part that I need to do is I will log into ECR and I will tag the image as per my requirement. And the next stage is, let's say, log into ECR and tag image. Tagging the image is very important. Now, how to tag the image and all, so that I will just show you. Okay, just go to your AWS account. I will remove this unnecessary tabs here. Go to your AWS account, go to ECR. It will give all the commands, so there is no need to search for any commands. I will just create a test repository. I'll show you what are the commands that are required. So just click on create, give any name test, let's say test. Just click on create. It will give you the commands. Okay. So just click on test, view push commands. It will show you how to log into ECR, how to build your Docker image, how to tag, what is the format standard naming convention used to tag the image, and how to push the image. So all these commands we'll be using. We will do it one by one. So first thing that I need to do is we need to log into our ECR. So just copy this. Okay, again, I will be needing the credentials, right? Access key and secret key. Because if I want my Jenkins to log into my AWS account, I will be needing this access key and secret key. So I will use this line over here. This line is important. Okay. And here I will write the commands for login to ECR and all. Okay. So inside this sh, I will add this command. Okay. And I will parameterize this. Now AWS ECR, this is the command, same command I have pulled out here. Okay, AWS ECR login password hyphen region US East one is fine. Docker login hyphen username AWS. This is something that I need to parameterize because see this is my AWS account ID. Okay, I'll just show you. If I close this on the top right hand side, you can see here this is the account ID, and the account ID will be different for your different users. Okay, this is my account, so it will be unique for different users. So this is my unique account ID. For you the account ID will be different. So I want that this account ID should also be passed as an input. Okay, so in the pipeline script this account ID should also be passed as an input. So for that what I will do is I will just parameterize it with the, let's say you can add any name. I will call it as AWS account ID, and this is a parameter, so I will give the name as params dot AWS account ID, and to call it I need a dollar symbol in the braces. So what it will do is, rather than using the unique account ID that my account has, I will just use a I will give the input to the user so that you can pass your own account ID, because your account ID will be different, my account ID will be different. So this is what I will parameterize. Okay, this part. Okay, so params dot account ID, and the rest of the parts over here, this what it will do is it will log into AWS with the parameter that is AWS account ID. Now this parameter I need to create it in my parameter block. Copy this. You can copy this entire line, paste it. Now what is the string? It is AWS account ID, right? Just copy it here. So this is what I have parameterized, AWS account ID. I will just pull it here, like AWS account ID. Now, what is the default value? So, whatever account ID you have, you can just keep the default, or I'll just keep it blank. And here you can give the message as enter your AWS account ID. Okay, so this is I told you right how to get the account ID. So the one thing I have parameterized is I have parameterized the account ID as well, so that it will be different for different users. So that is the reason I have parameterized the account ID. Now this is how it will log into my ECR. Right? So this is how it will log into our ECR, and then how to tag the image. So this is the standard naming convention that is followed to tag the image. Because see, we will be creating an image, we need to tag the image as per the standard naming convention followed in ECR. In Docker Hub, right, we follow some different naming conventions. So we write the we write the username / image name colon version number, right? If it is latest or v1 v2, that is how we write it in Docker Hub. But in ECR they follow a different naming convention. So we will follow the same naming convention. We will tag our image, okay, as per the standard convention followed in ECR. So just copy this command and over here just paste it. So this is how it will tag the Docker image. So Docker tag. Now this is the test name, ECR repo name that we have given. I don't want to use test. I want to use the ECR repo name, right? So whatever repo name has been mentioned, let's say Amazon Prime, so it should tag it accordingly. So here what I will do is I will pull the parameters, params.ecr repo name, copy it. Instead of test, just use this in test letters, just replace it with this params.ecr repo name. Okay, and this is again a parameter. I don't want to use the account ID. I will use the account ID parameter. So params.account ID, replace it here. So I'm just replacing the command. Okay, so it is, don't get confused. So it is something that I'm just replacing it. Okay, and params.repo name. So here instead of test, it should be params.repo name and followed by colon. So whatever image that is getting created, it should be tagged as latest. But I want that for every new build, I should store the version. It should store as versions. So let's say I'm doing the build from Jenkins. So the build number one will be stored as image number one. The build number two should be stored as image number two, because see, for every new changes, the developers will be requesting for new and new images that we will be needing to store. So what we will do is we will just use a standard environment variable used in Jenkins, that is the build number. So you can just search for environment variable Jenkins, which is build number. So this is a environment variable used in Jenkins with the name as build number. So whatever build that you will be doing over here, so let me just show you. So this is the build number. So this currently it is build number one. So the image will be stored as one. So let's say if you are deploying or if you are building a different image, the build number will get as two. It will become two, and the build number will change to over there. So this is the environment variable, right? So this current build, that is what I will be using, so that the images will be stored as per the build number in Jenkins. So this is fine. This latest, I will just copy this line and I'll just paste it here. And instead of latest, I will use dollar build number. So this copy it and just call it as dollar build number. Now these are some standard environment variables, so I don't need to define it here in the my pipeline. I don't need to define it over here, because these are some standard environment variables provided by Jenkins. So it will automatically pull out the build number and it will store the image with the build number, and that specific build number will be tagged as latest. So for the next build, so if I'm again running my pipeline, so the two will be tagged as latest. For the third build, the build number three will be tagged as latest, and that latest tag will be removed from the previous builds. Okay, so that is the reason you need to write it in this format. So the whatever build is created, that specific build will be the latest build. Okay. So this is how you can create the versions of different builds. If you want to use a specific version for deployment, you can just pull out that from the build number. Right? So this is how we do it in real time. Right? We just tag the image with build numbers, and the developer will say, okay, so this for this particular build number, I want a deployment. So that we will just pull out that image and we will do the deployment. Right? So this is the next stage, that we will log into ECR and we will tag the image, right? We will be tagging the image. Now next part is we need to push the image. Now where do we need to push the image? As I told you, we will be pushing it to AWS ECR, right? So the next stage will be push the image to AWS ECR. So instead of Docker Hub, we are using AWS ECR to store our images. Again, these credentials will be required. Now, the command, you can just pull it from here. Right now, what is the command to push? So this is the command, Docker push. So I'll just remove everything, paste the command, Docker push. Again, I need to parameterize this. So instead of this account ID, I will use the params.account ID. Okay, and instead of this image, I will use this one. So what I need to do, I need to push both the build number and the latest. So you can just copy this line and just paste it. Instead of latest, just copy this build number. Okay. So what it will do is it will push both the images, one image with the build number, and that specific build number will be tagged as latest. Okay. So the previous latest tag will be removed. Okay. This is how you can just tag your images with the latest tag. So once this image has been pushed to ECR, we don't need these images in my Jenkins server, because that will unnecessarily it will occupy some space. I have already stored my images to ECR. Okay, I have already pushed my images. I've already stored my from my Jenkins. I have already pushed it to ECR. Okay, so I let's say this was my image which was created in Jenkins server. This image is already pushed to my AWS ECR. Now this images will be using for deployment, right? So Jenkins created an image with the build number 1. The same image was tagged as latest. This image is pushed to AWS ECR. Okay. Now I don't need this image over here in my Jenkins server because it will occupy space. The images are around 500 MBs or 1 GB, sometimes 1.5 GB. So the size of the image can vary. So I don't need this image because I've already stored this image over here now. So I don't need this image in my Jenkins server. So I need to remove these images. Right? So what Jenkins will do, it will create the images like this: image number 1, image number 2, as per the build number, image number 3. Right? So for every new build, it will keep on creating these images. So I don't need these images in my Jenkins server. I need these images in my ECR repository. Okay, and the latest build number will be treated as will be given the latest tag. Okay, so the build number 3 will be given the latest tag. So whatever latest build you have, that build only will be given the latest tag. So that is what I have written in the pipeline script. Okay, so the latest build will be given the latest tag. Okay. So that is what I have written over here. This is what the line means. So this build number, according to this build number, that tag will be given to that particular build number. So let's say I'm building the build is 15. So the build number 15 will be given the latest tag, and the previous tags will be removed. The latest tags will be removed. Okay. So the latest build will be given as the latest tag. Okay. So once these images have been pushed to AWS ECR, I won't be needing these images here in my Jenkins server. So I need to remove these images. That is also required because the cleanup is also required, right? So for that, I will add another stage. I'll just copy this stage here so that this is the stage to clean up the images. So clean up images from Jenkins server, right? So for that, instead of this push, I will just write the command, and I don't need this with credentials. This part we can remove, and this extra bracket I can remove, and instead of push I'll just use RMI. RMI is a command which is used to remove the images, right? So it will just to remove the specific image with the build number and the latest tag. So these images will get cleaned up from my Jenkins repository. Okay, and these unnecessary images will not be stored. Okay, so this is how you can write the pipeline script. And another block that I want to add is a tools block. So this is where you can add the tools. So if you're using some specific version, here this is where you can define the tools. Now for JDK, I was using the tool that is JDK. I can just copy it from here. Okay, so I went to manage Jenkins, go to tools. So whatever tool name I have given, that tool name I need to add it here. So for JTK, I had given the name as JTK. So just copy and paste it here like this. And for Node.js, the name was, just copy the name from here. So what was the name given here? So this is the name. So if you're using some different version, just give the different name. Okay. So if you're using, you can call it as Node.js 16 also. So if you're using Node 20, you can give the name as Node 20. And this is where you can define the name in the pipeline script.
So this particular pipeline will pick up 16.20 Node.js version, and JDK it will pick up 17.0.8.1. Okay, so this particular pipeline that I have written, it will pull up only the JDK, and in the JDK the version is 17.0.8.1. So that specific version will be pulled in this pipeline script. So this is how we have written the pipeline script, right? So this is the build pipeline. So what it will do is it will do the git checkout, it will do the SonarQube analysis, it will do the quality gate, it will run the npm install, it will do the Trivy scan, it will create the Docker image, it will log into ECR, it will create the ECR repository, it will tag the image, it will push the image from Jenkins to ECR, and it will remove the images from Jenkins server. Okay, so that this entire script is available over here in my DevOps project number 2. So I can just copy it here. So this is the entire script that we have written. Right? This is the same one that I have mentioned in the notepad. You can just copy it and go to your Jenkins. Now here you can see in the SonarQube project, nothing is available, right? I need to create a project with the name Amazon Prime. So this will be done by my pipeline script only. Now go back to go back to dashboard, go back to the build pipeline. So this was a simple pipeline we had created with Hello World. Go to configure and just over here, paste the pipeline that you have written. Okay, this is the pipeline you have written, and just click on save. Now, since this pipeline uses some parameters, just build it and abort it immediately, because I need to give the parameters, right? We have set some parameters, and just hit on refresh. Now here you can see an option build with parameters will appear. Now this is where I need to define the parameter, or I need to give the input parameters. So just click on build with parameters. Now what is the repo name that you want to give? You can give any name. Okay, so this is totally customizable. We have already variabilized it. So if you, instead of Amazon Prime, if you want to give your name, you can give it. That is totally up to you. Okay, and this is where I need to provide the AWS account ID. Okay, this is where it will ask for AWS account ID. So just how to get the AWS account ID, again I'll show you. Go to the top right hand side, copy this account ID and just paste it here and click on build. Okay, now this is how it will create the build pipeline. Okay, so it will follow all the steps. It will do the git checkout, SonarQube analysis, it will do the quality get check, it will install the npm, it will do the Trivy scan, it will build the Docker image from the Docker file, it will create the ECR repository, it will log into ECR, and it will tag the image, it will push the image to ECR, and all these things will be done by this build pipeline. Okay, so mostly this is a continuous integration pipeline where we are building the images, and that image will be tagged as per the build number. So for this pipeline, the build number is 3. So in the ECR over here, you can see here, if you go to repositories, only test is visible. So I will just delete this. Now there are no repositories that are available, right? So this pipeline will create a repository, ECR repository, and it will tag the image with build number as 3 and tag as latest. Okay. Now also here, if I go to projects, you can see here it has created a project with the name Amazon Prime. Right. So let this pipeline get completed. I'll show you each and every stage one by one. So this git checkout, what it has done, it has gone to this particular repository. Right. This is my repository, and it has done the git checkout. Okay. So that is the first stage. SonarQube analysis, it will over here, it will check for the SonarQube analysis, and at the bottom you can see here execution success. So it has done the SonarQube analysis, and that SonarQube analysis you can check it in your SonarQube uh, tool, right? This is your SonarQube browser that you have created. This is your Amazon Prime repo that got created project. Okay, this is the project name that we have given. And here you can see SonarQube will show you different things. It will display the bugs, it will display the vulnerabilities, it will display the code smells. Okay, so I told you code smell. What is a code smell? So code smell is poorly designed code. So it will analyze the code smell, and this is the 5.1%. There are duplications. So there are around out of 14,000 lines, 5.1% you have used the duplicates in your code, and there are around 55 duplicate blocks. So everything it will analyze. Okay, and over here you can see the quality get status is passed, because there was some quality get state percentage that was set, and this is already been passed. And the same thing you will get it here in the stage number 3. You can see here quality get is okay. Okay, so this same message you can find it here also. So this is done, and the next stage is install npm. So if I just open the logs, go to shell script, so you can see here npm has been installed. Okay, and you can just ignore this. These are just error warnings. You can just ignore this part. Npm installation has been done. Trivy scan. This is the next stage. Go to logs. Now this Trivy scan, okay, it has scanned for the vulnerabilities. You can see here everything is it has scanned, and this scan results are stored inside your Jenkins server. So either you can go to your Jenkins server, or you can just click on over here in that build number 3. Go to workspaces, click on this, and this is the trivy.txt. Okay, so this is the vulnerabilities. Over here you can see here there is 14 medium, 9 high, 1 critical. So this is how it has generated the vulnerabilities, right? So over here you can see here these are the results that you can find. So this is just a partition. Okay? This is not some different language. These are all the results that you can find. So basis failed to limit the number of characters it can handle. So all these results will be visible in the inside this trivy.txt. So you can just mail this txt file, or you can use this txt file later on, right? So this is how you can find it inside the workspace. You can also log into your Jenkins server, and you can get this trivy.txt file. Now if I go back to my build pipeline, and you can see here the build pipeline is successful, and even that build docker image, if I go to logs, you can see here it has built an image with the name Amazon Prime. So this was the parameter that I had passed, Amazon Prime. If I pass some different parameter, it will take that name. Okay, so this is totally customizable, and I'm taking it as an input from the user, right? So it has created this build this image, and it has stored this image, right? So this build is successful. This is done. Creating an ECR repo. So let's see. It has login inside my ECR. It has logged into my AWS, and it has created a repository, ECR repository. So this is the code it had used. So I'll go, and we will just go and check. So search for ECR. So we are already inside ECR only. So just click on refresh, and you can see here Amazon Prime repository has been created, and within this repository, the build number 3 got created. Okay, so as per the build number, okay, so here you can see here the current build number is 3. As per the build number, the image will be stored as with the tag 3, and it will be tagged as latest. Now if I, let's say if I rerun this pipeline again, let me rerun this again with my account ID. Then it will create a build number 4, and that same image it will store. This 3 will this latest tag will get removed from build number 3. Build number 4 will get created, and it will be tagged as the latest image. So whatever new images you are creating, or whatever new builds you are doing, that will be tagged as the latest image. So that is the functionality of making use of this tagging of the images, right? So this is let this pipeline get run in the backend. So it has logged into ECR, and it has tagged the image. You can check here what image it has been tagged. So it has tagged it as Docker login. So it has taken my AWS account ID. You can see here, right? And this is the tag it has used. Docker tag Amazon Prime. Okay, so this is the image tag it has given. So this is the standard naming tag that we have used from the ECR repo. And it has logged into my ECR, it has tagged it, it has pushed the images to ECR. So that you can find it in the ECR repo. Right? So you can see here. So this is the image, right? It has pushed it to ECR. And if you just click on view push commands, these are the commands that you can use. So these push commands have been used in my Jenkins pipeline, right? And clean up images. So if I check my um, Jenkins server, so these images have been cleaned up. You can see here. So this was the image with the name 3 that was removed. The latest image was again removed. Okay, so these are the images that are currently available now. Okay, so if you want to remove these images, you can also still do it. So this was some SonarQube and Grafana images that I had pulled while running the Terraform code. So these are also unnecessary. You can remove these images also as well. You can log into the Jenkins server and you can remove these images as well. So this is the build pipeline, right? So this is how it will create the builds, and it will store the builds and it will tag with the latest images. Now moving ahead, we will see how to create and the release pipeline. We will see, how to, we will check how to deploy to ECR. So this build pipeline is completed. So this Jenkins created an Amazon build image, and this image we have already stored to AWS ECR. Right now, the next part that we need to do is we need to use this. We have already pushed this image to our AWS ECR. Right now, we need to use this image in our Kubernetes pods. Mostly for this, we will be needing an EKS cluster, and this EKS cluster we will create it with the help of Terraform code. So there is no need of any manual intervention. I have automated everything. So this Terraform code will create the AWS EKS, that is Elastic Kubernetes Service. It will create the cluster. It will create the node groups, and you can just deploy this image, that is the Amazon Prime image, in your Kubernetes cluster. Now see, as discussed in the DevOps project number 1, you can simply deploy the image by the help of deployment.yaml file and service.yaml file. So that process also you can use it over here. Okay, that part also I've already shown in DevOps project number 1. But in this project, that is DevOps project number 2, we will see how to use ArgoCD. Okay, ArgoCD we will use for continuous deployment. Okay, so that was a simple method that I had shown in DevOps project number 1, how to do the deployment using the um, deployment.yaml and service.yaml files. So these files I also have kept it inside my GitHub repo. So if you just go to the pipeline script, just go to your deployment pipeline. So this is the Argo CD pipeline. Go to the deployment EKS. So this is a simple pipeline. It will just pull up the region, account ID, repo name, version. So if you want to deploy a specific version, let's say I want to deploy version number 3 only, then if you want to deploy a specific version, it will take it as a parameter and it will deploy the specific version, right? And there it will log into EKS and it will select that particular version. It will rename it. So the SED we have used, search editor. So it will rename the image as per the input received from the user. So let's say here the user has given the image version as, let's say, version number 4. So it will replace it in the deployment manifest, and it will apply that deployment and service manifest. So this direct deployment can also be done with the help of this deployment underscore EKS. This pipeline you can use. But today we will see how to do the deployment with the help of ArgoCD, right? So that part we need to do. And so for that, what I will do is we will go to our Terraform, we will go to our DevOps project code, and here go to this inside the Terraform code. You can just minimize this EC2 server. You can see here EKS code is there. Okay, so this EKS code, just right click, open it in an integrated terminal, and if I want to reduce the path, you can just copy that commands again. So this command shall run. Okay, now if I do CLS, you can see the path has been shortened. Now what I will do is I'll run Terraform init. It will download the provider plugin in AWS EKS, and then we will run Terraform apply. Now what is this Terraform code? If I open it in here, so this is the Terraform EKS code, which will help you to create AWS EKS. So see, you can do create AWS EKS by login to your EKS. So from the console also you can do it, right? But that is a time taking process. So instead of that, I have automated it with the help of Terraform code. You can just click on add cluster, create cluster. You can do the cluster name, you can select the rules, you can select the version, and all these processes you can follow. But instead of that, I have just automated it with the help of this Terraform code, wherein what we are doing is we will we will use this different uh, VPC. We will create it in a private VPC. So we are creating it in this different VPC. These are the subnets that we will be needing, and this is the region that I have defined over here. And in this VPC, we have defined the VPC details, right? And this EKS code will create an EKS cluster. Okay, so it will create a cluster with the name Panda node. Okay, these are the node groups. Sorry, my bad. It will create a cluster node group with the Panda node. So it will create two nodes. Desired will also we have kept it as two. Maximum in case if there is a need of auto scaling, it will automatically scale to 4. That is the number of a maximum number of nodes, and we have used T2 medium. Okay, so these nodes that will be created, they will be created with instance type as T2 medium, and in this provider.pf, I have given the cluster name as Amazon Prime Cluster. If you want to customize it, you can just simply change the name. Also, if you want to give it, create it in some different VPC, that also can be done. So this is Amazon Prime Cluster that I will be needing to use, right? So this is the EKS code, and we have successfully initialized this code. Now, what we will do is we will run Terraform apply --- auto approve, and what this will do is it will create the required cluster and node groups, right? So this is the Terraform code which will help you to create the EKS cluster and node group. Now this is a time taking process. Now this will take around 10 minutes to create the cluster and node, and after the cluster and node is created, if you log into your AWS clusters, these clusters will still be in a creating state. That will again take around 5 to 10 minutes. So we will resume, and after this code is completely deployed, we will check the whether the clusters are created or not. Okay, and we will see, and we will wait until the cluster is completely available. Now you can see that the cluster is now in an active state, and if I open the code, you can see the apply has been completed. Okay, so it has applied and created the required infrastructure. So what we need is we will be the image that we have created. So this is the image. this image, we will be needing to deploy it in an EKS cluster. So let's say this is our EKS cluster. Elastic Kubernetes Service. That is what EKS is. So we will be needing to deploy it in an EKS cluster. Now see, as I told you already, you can directly deploy the image by using this script. So go to pipeline script. So if you can check this deployment underscore EKS. So you can use this script to do the deployment using deployment service manifest, and you can also pass the particular version. So if you want to deploy a specific image, you can pass it by with the help of the parameter. So this is where I have added the parameter where it will get the image name. So let's say, see, this is build pipeline is also completed. So I have built the fourth number build. So if I check the ECR repository, it will show me build number 3, build number 4, and build number 4 will be tagged as the latest image. So this is my repository, Amazon Prime, and you can see here build number 3, which was created previously, and it was also tagged as latest. Now build number 4 got created and it is tagged as latest, right? So the latest build will always be tagged as the latest image, right? That is what ECR will do. So if you want to deploy a specific image, you can do it with the help of this code. You can just paste this code in your Jenkins script and you can deploy it. So this part we have already seen in DevOps project number 1. But this is not what I want to do. I want to deploy the Amazon Prime image in an EKS cluster with the help of ArgoCD. So ArgoCD is a deployment tool. Okay, so it is used to deploy the Docker images on your EKS cluster, and it is kind of a continuous deployment tool. Okay, so you can just create the project and you can see graphically. You can also see the pods, you can see the deployments, you can see the service manifest. As compared to Kubernetes cluster, you can only see it with the help of commands, right? In the Kubernetes, we run the commands kubectl get service, get kubectl get deploy, kubectl get pod, and then only those pods, those services, those deployment will be visible. But here the case is different. With the help of ArgoCD, you can create an application on the browser. You can see it graphically. So that is the use case of ArgoCD. So it will be helpful for continuous deployment. Okay. So what we will do is we will first check the deployment script. You can call it deployment or continuous delivery, continuous deployment or release pipeline. You can give any name. Okay. So here, the pipeline is very simple. So I will not take much time for explaining. So this is where I will be passing the environment variable of kubectl. I will be using the cluster name as an input. It will take it as an input value, so that because you may give some different cluster name. So that is the reason I am taking it passing it as a variable. So what it will do, it will log into my EKS. Again, here I am using the credentials, access key and secret key, and this is a command which will help me to log into my EKS cluster. So once it logs into the EKS cluster, it will use the hem to create, configure Prometheus and Grafana. Right. So what it will do is it will use hem charts to configure the Prometheus and Grafana. Okay. So this we are doing with the help of hem, and hem is already installed in our Jenkins server. Okay. So this Jenkins server already has hem package already installed in it. And then what we will do is we will apply the ArgoCD manifest, and we will change the type from node port to load balancer, so that we can get a load balancer configured in ArgoCD. And also similarly, we will also get a load balancer for Prometheus or Grafana. And from this ArgoCD, we will get the endpoint of our application. So from that endpoint, we will be able to access our application. So this is an Amazon Prime clone. So that application will be accessible from the endpoint which will be generated by this ArgoCD. So what we will do is we'll just copy this pipeline script. So this script is also available here in the README file. So you can copy it from here as well. So this is the deployment pipeline. Copy it, go to your Jenkins, go to dashboard, click on new item over here. So we will create a new item with a name release pipeline or deployment pipeline, any name that you want to give. So let me call it as deployment pipeline. Select pipeline over here, this one, and click on OK. And here just paste the script that you have copied. Click on save and just first do the build now, abort it and build it again because we are using parameters. So we need to refresh it and use it, we'll build it with parameters. So you can see here now the option build with parameters will be visible. So click on build with parameters. So this is the cluster name that you want to give. So you can just go to your clusters. So this is the cluster name that the EKS cluster has created. And if okay, I'll just show you the cluster. This is the cluster, and in the compute you can see the node group. You can see here there is one node group over here. So this is the node group that got created, and these are the two nodes that are visible over here. So these are the two nodes, and these nodes can also be fetched from the EC2 console. If you open this EC2, it will create instances. So that instances are what we can call it as node group. So these are the Panda node. So you can see these two nodes got created with the help of EKS or Terraform code only. So we wrote the Terraform code, we run the Terraform code, and these nodes got created. So two nodes with instance type as T2 micro got created, right? So this is how you can check the nodes. So these nodes are created over here, right? Two nodes got created. So this is how our cluster was created. Now what we will do is we will pull out the cluster name here from here. This is my cluster name. Paste the cluster name, do the build, and it will start running the deployment pipeline. Now what this deployment pipeline will do is it will create Grafana with the help of hem charts. It will create Prometheus, and it will also create the ArgoCD application. Okay, so it will also create the ArgoCD application. Now this, if you want to check the services, you can log into your Jenkins server and you can check the services, right? How to log into your Jenkins server, we are already familiar. Just click on this Jenkins server. So just copy the public IP, open any tool like MobaXterm or Putty, or you can directly run it from command prompt, whichever you are comfortable with. So go to sessions. So this is my Ubuntu machine, so I will type as Ubuntu at the rate public IP of my Jenkins server, and I will use the key.pem. So this is how I can log into my Jenkins server. Right? Now let me check whether the pipeline is completed or not. So you can see here this pipeline got created. Okay, and here it got logged into EKS. Okay, so it used this command, and here we have variabilized this Amazon Prime cluster. So it has used this. It has used that variable, and it has also configured the Prometheus and Grafana over here, and it has also configured the ArgoCD application. Now we will be needing the URL of this ArgoCD and Grafana and Prometheus. Okay, so in order to get the URL, so you just go to my GitHub repo, and here you will find a script called access.sh. Okay, just copy this script. So this is a simple script. It will do the AWS configure in your laptop, in your in your Jenkins server. It will go to your Amazon Prime cluster. It will log into your EKS, and it will run some shell script commands to get the username and password. Now see it will take 1 or 2 minutes for these services to get created. So just after 1 or 2 minutes, just copy this access.sh shell script. Go to your Jenkins server and just create any file, access any file that you want to create. So let's say access URL, or let me just create it as access. Enter, paste the script. Just press escape colon WQ. Escape colon WQ you had need to press, and after that just do change mode a plus x access, make it executable, and just run this file with the help of dot / access. So what it will do is it will ask you the access key and secret key. So we already have it here. So this is my access key, paste it. Now it will ask the secret key. This is my secret key, paste it. Default region is US East 1. Even if you don't type it also, that is fine. You can keep it blank. So by default, the US East 1 is the default region. Enter. Now it has logged into my EKS cluster and it will fetch the required details. Now you can see here, these are the details that I will be needing. So this is the ArgoCD URL. This is the username password. This is the Prometheus URL and this is the Grafana URL. Okay, so we will check this one by one. So first I will go access my ArgoCD URL, copy it and go to your browser and just paste it, enter, and click on advanced and just proceed. So this is your ArgoCD application. And here we will be needing to do the continuous deployment. So it is asking for username and password. So you can get it from here. So this is the username. This is the password. So once you log in with this password, I would suggest you to change it later on. So sign in. So you can just go to, I think, user info to change the password, update password. So this is the current password, and new password you can just change to your any password of your choice, and just set the new password. Okay. Now you can go to applications and I need to log in again. So my password has been changed. Just click on new app and here you can give the application name. So I will give the name as Amazon Prime app, whatever name that you want to give. Project name, keep it as default. Sync policy, you can select automatic. And here repository URL. This is the URL wherein you need to mention the GitHub URL. So again, go back to the GitHub URL, copy this URL and just paste it over here. And this is the path of your deployment and service manifest. So I've kept it inside this Kubernetes underscore file. So this is my deployment.yaml file. Okay. And over here, I have mentioned the image name. So this image name I have taken from here. Sorry, ECR. So you can see here this, if I click over here, if I copy the URI, it will show me the image name actually. Okay. So let's say this is the image number 4. Okay. If I want to get the latest one, I can just copy it from there. Instead of 4, I can keep it as latest. I can just change it as latest. So this is the same image name. I've just copied the URI and I've just pasted it in my deployment.manifest and I've kept it as latest. So I will always be deploying the latest image. Okay, and over here I have exposed the container number, port number 3000. So this is my deployment manifest and this is my service manifest that I want to deploy it in my ArgoCD application. Okay, so over here I have just kept the type as load balancer and it will just create a load balancer and it will deploy the application, right? So here this is my deployment manifest and service manifest and this is the path that is Kubernetes underscore files. So I can just copy this path or let's say this path. This is my path. This is what I need to paste over here. And in the destination, you can just take this pop-up that is appearing, and then the namespace you can just keep it as a default namespace. If you want, you can create it in a different namespace of your choice. So just keep the namespace as default, and just click on create, and just close it. So it will start progressing. So it will start deploying your application. Meanwhile, while this application is deployed, what we will do is we will do kubectl get service -n, let's say ArgoCD. It will display me the ArgoCD applications, right? These are the service files manifest in ArgoCD. kubectl, let's say get service -n Prometheus. So it will show you the service load balancer of your Prometheus. So this is the Grafana endpoint, and this is the Prometheus endpoint. So this is the load balancer. So you can copy it, either copy it from here, or else you can already have the .access, right? This file. Run this file, it will display everything, right? Okay, so this is the same one. This is the thing that I have converted into a shell script. So this is the same endpoint of Grafana over here. You can see here AA35E7, right? So either of the thing you can copy, or you can just run the commands and you can get the URLs. Either of the way you can do it. So this is my Grafana. This is my Prometheus endpoint. So you can see here Prometheus is also configured. It will pull out the Prometheus. It will give the queries and all. These queries we will be entering in our Grafana dashboard. In case if this is showing as site is not reachable, just open it in a new incognito tab and just paste the URL. So Grafana will take some time to get active. Okay, so we can just leave it as of now. Now here you can see here that my Amazon Prime application is been deployed in ArgoCD, and this is how you can graphically view the service and deployment manifest, right? So this is the same manifest that you can find here. So kubectl get service, it will show me the load balancer of my application, okay, which is hosted on port number 3000. And if I do type kubectl get deploy or deployment, it will show me the deployment of my Panda Cloud app, right? This is my app I have deployed. The same thing I can graphically see it in the ArgoCD application, right? So this is my service manifest. This is my deployment manifest. This is my pod, which is in a running state. You can see here. So if I type, let's say kubectl get pods. So this is the pod name C4F87, right? C4F87. So same thing will instead of say checking it from the commands, you can graphically view it from the browser or from this Grafana from the ArgoCD browser. So that is one good use case of ArgoCD. You can see it, and also you can access this endpoint. Okay, so this one kubectl get service that I have run with the help of command. You can directly get it from here. So this is the same endpoint. Copy it and paste it here, followed by :3000 because I have posted it in port number 3000. Hit enter, and you can see here your Amazon Prime application is now available. Now, since most of the things will not function because you need an API, so just to make it simple, I didn't create an API and all because that takes a lot of time. But see, this is how you can deploy your applications. So this is the Node.js application, and this got deployed with the help of ArgoCD. So this is the endpoint that you will get. You can just paste it with the help followed by :3000, and this is how you can do the deployment. Now, let's say, for example, this is okay. So this is your ArgoCD URL, right? Let's say if you want to, instead of this big URL, you want to change it to argo.pandacloud.click, something like that. It should be user friendly. You can do it with the help of Route 53 service. So let's say, for example, I'll just show you one example for ArgoCD. Instead of using this complex URL endpoint, I will just show you how we can do it. So just go to your hosted zone. I already have created a domain. Now this is totally optional. I'm just showing it out of interest. I have already taken a domain with the name pandacloud.click. Now this is totally optional. I'm just showing it how we can do it. So let's say I want to create a URL. I can just create a record, and I want to create a record. Let's say argocd.mandacloud.click, and here I can just select alias, and the endpoint will be let's say load balancer. And what is the region? Region is US East 1. Okay, so this is my region. And what is the load balancer? So these are the several load balancers that are available. Now from this, I need to choose the load balancer of my ArgoCD. So it is A63044, right? So this 65456 digits, A6 A6E 3044. And the last 8856. This one 8856. This is the one. So just select it. Click on simple routing, create records. So it will create a record with the name argocd.pandacloud.click. Okay, so you can get it from here. This one. So this is the record name. Copy it and let's try to access it. You can see here instead of having a complex DNS name, I can just use it with the simple argocd.pandacloud.click, and I can access my ArgoCD application. Right. So this is just for your information how we can use Route 53 to create domains, and you can just redirect it with some user-friendly name. So I've just created a user-friendly name argocd.pandacloud.click, and with the help of this, I can again log in. So with the password and with the username and password. Similarly, you can do the same thing for Prometheus and Grafana, right? And your application also. So instead of giving this complex DNS name, you want that your user should be able to access your application. Let's do this also. So let's say, for example, I can create another record. I will give the name as app.pandacloud.click or Amazon Prime, something like that. Amazon Prime, or let me call it as app.pandacloud.click. I can select alias. Endpoint will be load balancer, and the region is US East 1, and the load balancer is 1266. So I think it is this one. Selected, create records. Now this has port number 3000. So let's see whether it will work or not. I think so. It will not work. We need a Nginx server for redirection. So this will not work because this will not function like this. Because it will not. Okay, so that can be done by redirection with the help of reverse proxy. We can use Nginx for that. Anyways, I just wanted to show you how we can make use of this Route 53 domain. We can create our own, user-friendly domains. So we had created this the argocd.pandacloud.click, and we can access our ArgoCD application by a more user-friendly name. Right. So this is how we had done it. So let's see whether Grafana is on. Um, Still not started, I guess. So Grafana will take some time. Okay, it will take around 5-10 minutes. Okay, now my Grafana is now accessible. So if in case if it is not accessible, just double click on this. You can just copy the URL. It will take around 5-10 minutes for Grafana to be live. Okay. In case if it is not accessible, what you can do is just double click on it. Instead of HTTPS, just change it to HTTP. So over here at the as a prefix, instead of HTTPS, just type it as HTTP. // and it will get accessible. Now it will ask for username and password. We have already run our script here. So this is the username, that is admin. From operator is the password. Admin, just paste the password. And you can see Grafana is now accessible. Now, we need to get the queries from Prometheus. Okay, so this is our Prometheus server. And from this, we will be creating a custom dashboard, which will show us the status of our pods. So what we'll do, we'll create on click on new dashboard. Here, just click on import dashboard. And here, search for one node exporter full, that is 1860. Click on load. So this is a very good dashboard, node exporter full. And here, over here, select Prometheus. So this is how it will get integrated. And click on import. So this will import the dashboard, and you will be able to see the status of your pods, the CPU utilization, RAM, and other uptime and all. And in here, over here, you can just type last 5 minutes, and the refresh interval, just keep it as 5 seconds. So you can see that the values will keep on changing every 5 seconds. So then now see the CPU is 2.9%, the system load is 7.0, RAM you use is 34.7. So you can see here these values are now dynamic because we have changed the value as 5 seconds. So for every 5 seconds, these values will keep on changing. You can notice that these values are changing. So this is how you can make use of Grafana dashboards to monitor your pods, right? So this is how you can see 42.6 minutes the pods are up. Okay, so it will show the uptime and all. So all this data you can see it graphically with the help of Grafana. Now moving ahead, let's see how to do the cleanup, because see, cleaning up is also important, because you will be creating this project, and it will be creating several services in AWS, and I don't want that you should get some charges and all. So what we will do, we have created a cleanup pipeline, so that will clean up the services and deployment files of Grafana, service and deployment file of Prometheus. It will delete the ArgoCD manifest and everything, all the certificates and all the services and deployments, everything. It will also it will also delete the application that you have created. So this is the cleanup step now. So it will also delete the application that we have created. It will also delete the ECR repository that we created, and the Terraform code that we created to generate the AWS EKS, that will also create some KMS keys. So these keys are also something that that are that will get created in your account. So you can check it over here. Let me show you. So if you go to your AWS account, so this is your ECR repository. So we need to do the cleanup of this repo, right? For this, we need a script. Also, it will create some keys in your KMS. So these keys, if you don't delete it, or if you don't schedule the deletion of your keys, then they will create unnecessary charges in your account. Okay, so once you are done with the practical, so you can just run the cleanup pipeline command, and these keys that are created, whichever keys are already scheduled to deletion, that is fine. So it will throw some error. If your keys are already scheduled for deletion, then it will show that these keys, specific key is already scheduled for deletion, and whatever keys got created additionally, so this is the key which got created additionally, this key is something that we need to do the cleanup, or else you will start getting charges in your account. So for that, I already have written a cleanup pipeline. So you can go to the DevOps project, you can go to pipeline script. There also I have the cleanup pipeline, or you can just scroll down in the README file. There also you will find the cleanup pipeline. So here, this is the cleanup pipeline. Just copy it, go back to your Jenkins, go to dashboard, uh, click on new item, and here just write the project or pipeline name as cleanup pipeline. So this pipeline, as I told you already, it will do the cleanup of, it will delete the service and manifest, deployment manifest of Grafana, Prometheus, and ArgoCD. It will delete the ECR repository, and it will also schedule the KMS deletion. Now these keys will not get deleted immediately. they will get deleted after 7 days. So that is the scheduled deletion period. That is the default period which is set by AWS. So the minimum period is 7 days, the maximum period is 30 days. So we have created the script in a way that it will schedule the deletion within 7 days. So after 7 days, these keys will get deleted. Okay, so these keys that you can see here, they will not get deleted immediately. It will take around 7 days. So it may also throw an error for the deletion of keys because this we are trying to clean up all the keys. So this is a shell script command that I've created. So it will clean up all the keys. So this is the command that will delete the ECR repository. Same you can find it or you can Google it and you can get this command. So this is the reverse command that we are using. In the deployment file, we have deploying the Prometheus and Grafana with using hem charts. We are just deleting it with the help of hem. Okay, so we are just removing the hem repo. We are just deleting the namespaces. Everything we are doing it in your cleanup pipeline. Again, we are trying to log in inside the cluster. Then we are trying to clean up all the services, Kubernetes files, and manifests. So just click on save and run this pipeline. This will do the cleanup job. It will delete the ECR repository and it will also this application, this everything will become unaccessible. Okay, so all these application will become unaccessible now. And we can just simply delete the record here if you have created any record. As I told you already, this Route 53 part is totally optional. So this is something that I wanted to show it to my candidates. From the AWS batch. So you can use this Route 53 to create the hosted zone and use a user-friendly name. So you can see here, if I now hit refresh, now there are no repositories, or let me check the pipeline first. So this is still running. In the logs you can find here, it is trying to delete everything. So it has deleted the Kubernetes manifest. It has deleted the Panda Cloud application. So if I try to access my application, this if I copy and paste it here in the new tab, you can see here this application is not accessible now. So this application is deleted. And another thing is that it has deleted the service files of Panda Cloud application. Then it has also deleted the ArgoCD application. Now if I try to access my ArgoCD here, so this is my ArgoCD URL. If I try to access it, it is inaccessible. This site can't be reached, right? Because this the cleanup has done. Similarly, it will start cleaning up other things. You can find here that it has deleted all the ArgoCD application. It has also cleaned up Grafana, I guess. So yes. So here you can see here, it has deleted the namespace ArgoCD. It has deleted the it has listed the Prometheus hem charts and it has uninstalled Prometheus. Okay, so Prometheus is uninstalled. It has deleted the namespace of Prometheus. So one by one, it is doing all. It is taking all the actions. So this list will keep on adding up. You can see here it has also removed the stable repo for Grafana and it has removed the Prometheus community. Everything, the Grafana and Prometheus, everything is deleted. And as I told you already, it will throw an error, but you can ignore it because some keys we have already scheduled to deletion, so it will just show an error that uh, uh, we cannot disable keys which are already uh, which are already been disabled. So you can ignore this. This is just an error that you will get while doing the cleanup. So the cleanup is done. Now we also need to, you can see here if I refresh the ECR repo, no repositories are found now. So ECR repo has been cleaned up. Grafana, Prometheus, and my application got cleaned up. Now you can see here my Jenkins and SonarQube is still working, and my EKS is also still in a running state. So how do I clean up these EKS and uh, uh, Jenkins server and all, right? So that is the next part. That is cleanup. We need to do the cleanup using Terraform. So from the Terraform command only, we can run the command Terraform destroy, and it will destroy. First, it will destroy. We need to destroy the Jenkins server along with the SonarQube server, and we need to also destroy the AWS EKS. So with the help of Terraform only, we will do it. So for that, what we will do? So this is my EKS cluster, which is still active. You can see here, And if I search for EC2, you can see my EC2 instances are still in a running state. So I need to do the cleanup of this. So my Jenkins server needs to be cleaned up. So this is my Jenkins server. This is my EKS cluster. I need to clean up this as well, right? So this nodes also I need to clean up. This Jenkins server I need to clean up. So for that, again, go back to your Terraform code. So over here, you can see here, there are two tabs. One tab is related to your Jenkins server. Another tab is related to your EKS. So this is Jenkins, this is EKS. So you can run the Terraform destroy command in both of these tabs. So Terraform destroy --- auto approve. So it will destroy all the resources that were created by Terraform. So it will destroy the Jenkins server and all. And the same command I will run here, Terraform destroy in my EKS. So first we will destroy the EKS, and then after that we will simultaneously we will destroy our EC2 instance as well. So I'll run this command also, and it will take around 5 to 10 minutes, and it will clean up everything. Okay, so the cleaning up of the EKS cluster will take a while. It will take at least 5 to 10 minutes. EC2 instance will get terminated within 2 or 3 minutes. So you can just run this command, and the resources will get destroyed. So you can see here now the resources have been deleted. So Jenkins server took around 1 minute 14 seconds for deletion, and the EKS cluster it took around 10 to 15 minutes for deletion. So it will take some time to get deleted. If I try to uh, check it in my instances, if I hit refresh, it is I will re-log in again. So if I check my instances now, you can see here there are no instances in a running state. And if I just refresh this cluster, you can see there are no clusters currently available. So Terraform has not only created the resources, but we also deleted all the resources that got created, so that there are no charges that will get incurred in our account, right? Now, one more thing that once if you want a write-up of this project, once you clone the GitHub repository in your local machine, you will get something called as project write-up, a Word file. You can refer that Word file, and you will get a write-up of the entire project over here. Okay, so this can be helpful if you are doing a project. If you need a write-up, you can get the entire write-up. So once you clone the project in your laptop or in your local machine, you can find the a Word file over here. Okay, so thank you, everyone. I hope so. You got to learn something new from this project. Okay, so we have done everything. We have automated everything with the help of Terraform. We created the Jenkins server with the help of Terraform. We created the EKS cluster with the help of Terraform. So everything got automated. Even the Jenkins URL, the Jenkins password, each and everything was automated. So there was no need to log in inside Jenkins, or there was no need to access any applications. So everything is something that we have automated with the help of this project. So as I told you, we'll be starting a new AWS batch from 21st of October. If any one of you are interested in learning AWS and DevOps, you can get in touch with the admin. So now the numbers has been provided over here. You can contact us. You can connect with us on mail. So pandaforcloud@gmail.com, and we have our YouTube channel Panda Cloud. We are available on Google Maps, LinkedIn, Facebook. So you can connect with us via any of the social media platform. And yeah, thank you everyone. Thank you.